Okay, so we're looking at section 4.1 today, maxes and mins. And so, if I were to draw the picture of a function, I think it's pretty straightforward to see what we might be meaning when we look at maxes and mins. Right, so I might have some function here defined on the interval from a to b, and I may ask, well, what is the maximum and what is the minimum? And so that's pretty easy to figure out if you're just looking through here. It looks like looks like those are approximately the same height, right? So we would say the maximum would be this value. This is the maximum value of y, max. And notice that the max is a y value, right? And then the minimum, if we go down, what is the smallest y value you can see on this graph? It looks like it's down here, right? And so that's the min. Notice, by the way, that if I had made this an open circle here, would the function still have a minimum? Well, there is still what we would call this is this would be a lower bound. A lower bound for f. But there is no smallest number, but f itself, the range of f has no smallest number, right? And so what you can think of this is the function has a lower bound, but it does not attain its minimum, right? So it does not attain its minimum value. And so in this case, even though the function is bounded, it does not have a lowest number. Okay, so then I could solve that pretty easily if I close up the circle, and then the lower bound would be included in the range of the function, right? So when we say that f has a local max or min, we're saying that local max or min is part of the range. Good. So in this section, we're going to be taking a look at when we can find maxes and mins, and we want to develop some kind of logical process by which we can determine where they are. So before we can do that, let's just get a few definitions here. If you look at this picture, this was the max and this was the max, but if I hadn't drawn the entire curve, if I had only looked at the curve from here to here and erased everything else, right, then it looks like there is a point here that, like the point at A here, if I blow this up, let me move the axes. If I blow this up, right, it looks like there is a point here. And so if I just draw this piece of the graph, right, it looks like I do have a max, a different max. And so the difference between this max and the graph's max, the full max, is we're going to call this a local max, right? And this would be the global max. Okay, similarly for a minimum, if you were to, let's get rid of all this stuff. Oh, in fact, let's just go ahead and draw another graph. So if I were to draw another graph, maybe like that, right? You see that there's a minimum here that's just local, right? If I'm just in this small interval here, I see that I have a minimum there, and then if I'm in this interval here, I see that I have a minimum here. So these are, again, going to be called local minima, and then this would also be a global minimum. And so let's write down some definitions. Definition: f has a global max at, let me erase that, x equals a, if f of a is the smallest number. If f of a, or smallest, greatest number, greater than or equal to f of x. And then that's for all x in the domain. And here's the point from the previous example here. Oh, I erased it. When this function came down like this and then it was open here, do you see why we didn't have a minimum? Because the minimum has to be f of a, right? It has to be a point of the domain, or a point of the range. A has to be in the domain. Good. Okay. So similarly then, f has a global min at x equals a. Can you guess if f of a is the smallest value for all x in the domain? Good. And then, whoops, I'm getting some weird stuff popping up here. I've never seen that screen before. Oh well. Definition. Okay, definition. F has a local max at x equals a if there is an open interval about x equals a on which f of a is greater than or equal to f of x for, and this is the important part, for all x in the interval. Do you see how that matches with our picture from before? So if I have just a local, well, if I have a function like that, right, I'm just focusing in on this local point here. I'm saying this point here, this is going to be the interval that I'm talking about. So this, notice by the way that I'm not including the endpoints because I want an open interval. So an open interval is an interval that doesn't have endpoints included. And so in this case, right, you see that the point at the top of the hump here is bigger than any other value just in this interval, right? Good. Now I should also say, maybe I should ask this as a question. Can an endpoint, can we have a local max at an endpoint? In other words, let me remove all this stuff here. How about a function that looks like this? Can I say that I have a local max at x equals 0? The problem is that you cannot get a full interval about this point, x equals 0. Since we can't get an open interval in the domain that contains 0 in this point, or in this instance. So this would not be a local max. And in fact, so what we're saying here is that, let me erase my star here and put in a new star. Local maxes cannot be at endpoints. Okay, and that is by definition. By definition, we are excluding endpoints from being local maxes. Good. All right. So how about a local or a global min? Oh, I guess we did do a global min. Local min would look almost identical. Whoops, sorry about that. Local min would look almost identical. If I change the word max to a min, then what changes? This is just less than or equal to then, right? So that's the only thing that changes for a min. Good. Now, so far we've been talking about maxes and mins, and some things are true about both things simultaneously. So there is a word that we can use. Let me switch back to the color, vocab. An extreme point, whoops, sorry. An extreme point is either a max or min, or both. So what I'm saying is that if you're looking for the extreme points, so if we say look for extreme points of f, we're looking for both the max and the min. Okay, so we're kind of putting them together. Very good. So in the next video, we're going to be talking about where the maxes and mins might occur, and we'll take a look at a little bit of theory, and then we'll try working through some examples.